In the following question, it is given that there is a set S is equal to 1, 2, 3, 4 to 2014. This is a set given for two distinct subsets U, V of S. For any two subsets U, V belong, which is a subset of S, U is less than V if minimum element in the symmetric difference, that is U symmetric difference V, belongs to U. Means that symmetric distance is U union V minus U intersection V. If the result of this belongs to U, means U is less than V, or if U union V minus U intersection V belongs to V, means V is less than U. Both can be the case. So we are taking three subsets. Since we know that every set S and empty set phi are the trivial subset, so phi is, I am taking first set S1 is equal to 1, 2, 3 to 2014 itself. Since S, every set is subset of itself and phi is also a subset of every set. So first set I am taking S is equal to this one. Second set I am taking T is equal to, let's say, 4, 5, 6. Third set I am taking, say, U is equal to 5. Now we will do symmetric difference between 1 and 2. On doing symmetric difference, S symmetric difference T is equal to S union T minus S intersection T is equal to, when we do S intersection T, it will be the set S itself 1, 2, 3 to 2014 minus S intersection T will be the T, that is 4, 5, 6. When you do symmetric subtraction, we will get 1, 2, 3, 4, 5, 6 will be excluded, 7, 8, 9 and so on. So minimum element in this set is 1 and it belongs to set S. So from here we conclude that set S is less than set T. Now think that you take any other subset other than T, and when you compare with S, you will find that S will be smaller than every other subset. So if it is smaller than every other subset, there is a statement, there is a subset of S that is smaller than every other subset will be correct. So S2 is correct. Now finally I am going to compare second and third, that is T symmetric difference U is equal to T union U minus T intersection U. T union U will be 4, 5, 6 because U is empty. T intersection U will be empty because 5, because U is empty. When empty set is subtracted from 4, 5, 6, result will be the set 4, 5, 6 itself. Now this is the symmetric difference of T and U, and in the symmetric difference the minimum element is 4 and 4 belongs to the set T, so T is less than U. Since T is less than U, Now you can think very easily that take any other example and do symmetric difference with u, and you will find that u will be greater than, or in other words, every other subset will be lesser than u. So there is a subset of S that is larger than every other subset. So this statement is also true. Since S1 is correct and S2 is also correct, so our option will be A.